to complete the square involves converting standard form into vertex form, and this could be useful for a multitude of reasons. It allows you to identify the transformations applied on quadratic functions a lot easier, as well as there's more identifiable features such as the vertex and the dilation that you can see, which is not readily available in the standard form of a quadratic equation. And it's also useful for solving the quadratic equation itself. So let's walk through some examples. Okay. So the first example we're going to walk through is x squared plus 2x plus 1. So we know when we have to complete the square, we want to divide this central term by 2, assuming that the lead coefficient of the x squared is 1. So we'll go to x plus 1 squared. No dilations applied, and we want to make sure that the function remains equal. Carry over the plus 1 from above. So we have to think about what is the constant that is produced out of x plus 1 squared. And when you expand x plus 1 squared, that is x squared plus 2x plus 1, which would not be included in the original, so we would have to subtract 1. And now this equation maintains the equality from the previous one. So now we move it down and we go to x plus 1 squared, and we have just completed the square. And now we could identify where the vertex is in the vertical dilation. So next we're going to do negative x squared plus 4x plus 5. And we have to identify that there is a negative 1 over here. So in order to complete the square, we must factor that out. And what's important to know is that we're only going to factor it out from the x terms. And this equation is still equal because we have not manipulated it in any way except factoring out a negative. So now this is a more readable form to complete the square. So we have to divide the 4 term by 2. Then we produce it back into the vertex form. Now we have to look at what negative 2 squared is. So negative 2 squared is positive 4. It's positive 4 multiplied by negative 1 coefficient at the front of the parentheses. So overall, this part, the function, will be subtracting by 4 from the original. So in order to maintain equality, we'll have to add 4. Okay, this will be the final problem of the video, and important to note is that we want to complete the square for both x and y in this problem. There was no difference in the way you complete the square for both variables. Just make sure to convert it to vertex form and make sure equality is maintained throughout the process. So we are going to divide. There's no coefficient ahead of x squared, and it's plus 4x. So we are going to divide 4 divided by 2. Add that. Then we're going to square that. 2 squared is 4 times 1 in the front. That would be minus 4 to maintain equality. Then we want to look at y squared plus 2y. There's no coefficient ahead of y squared, and we could treat this similar to x squared. It's really no different. It's just a variable that we're completing the square on. So 2 divided by 2 is 1. Able to maintain equality, 1 squared times 1, the coefficient of the parentheses. We have to subtract 1 to make sure it remains equal. We leave 13 on the outside. Now all we need to do is to simplify this equation for the circle. Add 4 to the other side. And we'll get a total of 16. So by completing the square, we can identify the circle with the center -2, -1, radius of 4. Thank you.